Alright, we're back. So, had our break. I'm going to set the timer again. I want to limit these to 5 minutes, as I said before, so 5 minutes on the clock. Here we go. What do we got here now? Focal length. So we spoke about focal length. There's a bit more to add to the focal length. Well, actually, more to add around the aperture. So the number, the aperture number, you know how you got that f1.2, for example, which is really excellent. That's how wide that thing is. Sorry, how the opening of the lens aperture, that's typically pretty darn wide. It's a ratio. That f1.2 is actually a ratio, and it's the ratio of the number of times the diameter of that opening, so the equivalent of your pupil, the size of the opening into the focal length of the lens. And you can see on the telephoto lens here with the variable magnification, that means that that ratio kind of changes a bit as you move this telephoto between 24mm and 107mm. Gets a bit technical, but if we use a different example, say a fixed prime 50mm lens, fixed prime meaning basically it's not a telephoto lens, it's 50mm fixed, 50mm distance between the focal plane of this, or so the lens, surface of the lens, the rear element of the lens, and the sensor or the film, 50mm, so 5cm distance, fixed. You can't change it. This one here you can change between 24mm and 107mm, so it'll move the rear element from 2.4 centimeters to 10.7 centimeters. That's why those telephoto lenses are typically so long, because there's a tube where you need to move that element from a wide angle to a narrow angle, and that is about 10 centimeters difference, hence the length of those telephoto lenses. You can do magic with the lenses now and make them a lot shorter, but they're more expensive because you've got to do a lot more lens work, whereas a purely mechanical device to move the lens from one spot to another is generally fairly less engineering, therefore cheaper. Okay, so 50mm lens, so with a focal length of 50mm and an aperture, say it's 5 centimeters, that'd be awesome. That would be 5 into 50 would go, that's not right, oh, it's in centimeters. So if it was 5 centimeters and 5 centimeters, that would be a focal, f-stop of equivalent of f1. There are some super expensive lenses out there which are 0.97 or something like that, which means they've got the lens where the aperture, the opening, is bigger than the focal length. So you'd have a bigger distance into a smaller number, and of course then you get less than 1. So that means that's super wide. That's so much lighting. You could use that thing in low light situations where you wouldn't be able to use other lenses, because it lets so much light in. Because remember, this whole thing is about capturing light, and so the more light you can capture in the less time, that gives you more flexibility. You can make things, you can capture things that you couldn't normally. So anyway, that's the idea here, is that it's a ratio, and as you move the aperture in and out, it's going to change that ratio, and hence you get these wacky f numbers. So you got f1.2. I can't remember all the numbers now. Unbelievable, so bad, isn't it? Anyway, so sometimes you go, f2.0. Forgotten, say 5.6, etc. What's happening here is basically these ratios are just that. They're a quick, dirty, simple, easy way to work out what is the equivalent of one exposure value that I can then increment and change exposures. So you know on the cameras you've got minus 1 EV, plus 1 EV, 0 in the middle, and then minus 2, plus 2, -3, +3 in some cameras. That's letting you quickly change the exposure value through 5 minutes again. Let's continue.